Today I am going to present my project AI Fairness Auditor, which is designed to evaluate whether a dataset used in AI system is valid, reliable, and fair. The main problem this system addresses is that many machine learning and AI algorithms which are trained on datasets that may contain hidden or imbalance. If the dataset itself is biased, the model built on the top of it will produce unfair or unreliable result. This issue is often not visible during development. My system solves this by providing a transparency and fairness auditing layer that analyzes datasets before they are used for training or decision making. So now here I am taking two things into consideration. First is showing the results of the dataset before the model is trained and after the model is trained. So we will test two cases here. First one where the model is totally fair. So in this, it will take the metrics. It will take the metrics of the dataset and display it here in a form of graph. Here we are using chart.js and we are using Grok to explain the chart, like key findings, evidence, recommendation, and risk, if any. So here, since there is no such risk, so it displays that no risk is present in the chart. Then a Grok audit report where it displays the executive summary, dataset model composition, most affected groups, bias risk analysis, fairness metric findings, legal and ethical implications, future risk assessment, and recommendations. Since this model is not biased, therefore the final verdict which is being shown is pass. Now we will test for an unbiased model. In the unbiased model, same, we can see the metrics. For metrics part, I'm using Fairlearn, which is ML part in Python, which analyzes the data set. Then bias detection alert is given here. Since the bias is based on race, so it is properly explained why the bias exists and what to do. Other than that, a proper graph is given here with key findings, evidence, risk, and recommendations. And same AI audit report, since the model is unbiased, be considered to raise, it shows the result as critical. Now, here this is a bias optimizer simulator where we can change and check for the bias. In this example, we focus on a protected attribute, gender or race. Initially, the dataset shows a near balanced distribution, about 51% male and 49% female. However, the system still detects bias reflected in a bias score of 73.1 out of 100. To reduce this bias, we applied a rebalancing strategy, which with a desired target of 59% male representation. 51% male representation and 48.9% female representation. But there's the key insight. Instead of improving fairness, the bias score slightly increased 73.1%. This means the system actually became more biased. Why did this happen? Because the target distribution itself was not fair. By increasing male representation and reducing female representation, we unintentionally amplified the imbalance instead of correcting it. This demonstrates an important principle in responsible AI. Optimization only works when the objective is truly fair. If the target is biased, the system will reinforce that bias. Our simulator not only highlights these outcomes but also provides analysis and recommendations. In this case, it suggests using more balanced targets and diverse data to achieve meaningful fairness improvements. Now we will move on to the post training part where the model is already trained. Here we will select and post-training hiring dataset which is already biased. Here we also put the input and model prediction data. This is the data set of the model which has already been trained. So I have uploaded the input and the predictions file. So this model will do the analysis on the input and the predictions and give a proper result displaying the bias. So here we can see the bias is detected, which is based on age. Where bias exists, it is properly explained. For the bias exists for age and race section. So here a proper explanation is given based on the graphs. Here we also have a synthetic testing where the model is tested based on the sample JSON rows and a Python function which can be auto generated with Olama. Protected attribute. Here we can see that the prediction model remains largely unchanged, suggesting that changing genders does not significantly impact the outcomes. Evidence: Group 0, Group A, Group B, Group C, Group D, affected groups. No affected group gap is within this acceptable range. Risk critical. Since the risk is critical, therefore, this dataset is totally disapproved. Now, in this is another feature that this is appeal engine. So whatever, like if you are applying for a job and you have a resume, for example, over here, this is the resume. I will copy my resume. I'll paste the resume here. Then the I will paste over here the company for which I am applying. So it will do a proper analysis that based on my data set, which is my resume, will I get applied in this company or not? Or what is the chances that I will be my resume will see be that there is a 80% approval score based on the resume. So match requirements, missing requirements, no direct mention of any experience with Amazon or cloud services. So it properly explains what requirements there should be in your resume so that you can change it, which will increase your chance to get an interview in Amazon due to the high ATS score. Now we will be checking for loan. We have enter all the details about the one who is applying for the loan, employment, and everything. So here the it shows 50%, 40% score because the missing requirements are employment stability in 8 months, which may not meet the required stability criteria. So it properly explains that why the loan is rejected. And these are the reports. The database it is stored in the database, so you can view the past report with proper analysis and everything. To conclude, this project is not just about detecting bias in datasets, but also about stopping biased AI before it even gets trained. Because in real world systems, fairness is not fixed at the model level, it is decided at the data level. If the data is unfair, every decision built on it will scale that unfairness silently. Thank you.